I think one of the things I've observed is that when you get started with a new technology, it may be in a university research lab, you might have a sort of technology vision, but often that's completely unconstrained. We want to build a fault-tolerant computer. That's it. That's the thing that will win us the Nobel Prize. And beyond that, it doesn't really matter. But we all know that in the world of real technology and business, there are lots of constraints. And I think actually, by the way, working within constraints can be a really creative process. But you've got to learn to do that. And that constraint might be, well, okay, we can build this thing, but at what cost? At what cost to the customer? What value will it provide? Or any one of a number, like a time frame. Like we want to build this thing, but do we want to take 15 years to build it? Do we want to take 10 years? But adding in constraints to your definition of the technology vision you have in order to lead to a more sort of outcome-driven mission, more application, if you like, driven mission, I think is really important.
Welcome to the Lab to Market Leadership Podcast. Too many advanced science and engineering companies fail to deliver their innovations from the lab to the market. We're on a mission to change that. My name is Chris Reichhelm, and I'm the founder and CEO of Deep Tech Leaders. Each week, we speak with some of the world's leading entrepreneurs, investors, corporates, and policymakers about what it takes to succeed on the lab to market journey. Join us. What are the trade-offs that deep tech innovators need to make in order to realize their ultimate innovation? That is the topic for today's discussion. And to help bring this to life, we're going to set this topic against the context of quantum computing, which perfectly illustrates, I think, the inherent conflict. What do I mean by this? There's a lot of talk about what the world will look like, about the problems we're going to be able to solve when we have realized truly fault-tolerant, full-stack quantum computing capability. Better drugs will be discovered in a faster period of time. We'll be able to develop novel advanced materials. We'll be able to better model more accurately climate change, and so on. And if we're a company like, let's say, Google, which is very active in the field of quantum computing capability, with lots of money to throw around and invest, we can almost pursue this task in an academic/R&D type way. Hire the best scientists and engineers, incentivize them, let them get on with it. It's not as simple as that, but you know what I mean. But if we're just about any other company, and especially if we're a startup, that's not possible. And why? Because too many stakeholders around the table need to have value developed along the way. We can't wait to get to that point, which may be realizable 10, 15 years away. Maybe it's not that long now, but again, you know what I mean. So we need to demonstrate that we're delivering value along the journey. And in order to deliver value, that means we have to develop commercial value. So how do you make a project that's in motion commercializable? And I guess that's what this topic is all about. Where are those compromises? Where are those trade-offs? Where are the trade-offs technically, operationally, and commercially? To help me get into this today is Richard Murray, who is the co-founder and CEO of Orca Computing. And Orca is a UK-headquartered University of Oxford spin-out, which is developing full-stack, fault-tolerant quantum computers. But they're not doing that right now. They're on a path that may or may not get them there. And so along the way, they're going to be making these trade-offs that I've just referenced, technically, operationally, commercially. Where is the line drawn for Richard and his team along that path? That's what we're going to get into today. I'm certainly going to get a huge amount out of this. I hope you do too. Let's get into it. Richard Murray, thank you so much for joining me.
It was great to be here. Thanks for having me.
Take us back, if you will, to when you and your co-founding team decided that it would be a good idea to build quantum computers. What were you guys thinking at the time? What was the vision? What was the motivation? And what was the anticipation? What was the expectation? Sorry. What was the expectation? What did you think
Yeah,
you would build?
that is a great question. And if you don't mind, there's a complicated story that I'll unpack a little bit for you because so I am not the academic behind the company. So in fact, my journey, I have a PhD from a long, long time ago, but I was working for the UK government on the quantum program that I helped set up. And then, I've been in and out of technology consulting on the commercial side. So I came to this through the lens of being involved in quantum, involved in the policy behind quantum technologies, quantum computing. But actually, I went around the country and met lots and lots of different academics with lots and lots of good ideas before meeting Orca's two academic co-founders. So Professor Ian Walmsley and Dr. Josh Nunn, they were the ones who'd been working in the lab to develop this sort of cool technology. But in the middle of those two backgrounds, I think comes a really interesting story that relates to what you were describing. So on the academic side, they'd been working a lot on quantum networks, these sort of big optical networking type things. These things can be useful for lots of different things. They can be useful as networks, both quantum and classical, and the academic team found that they could also be useful for computing. So when the academic team met, we knew each other, but when we sat down and talked about what Orca could be, there was a huge range of different things, some of which were not quantum computing, which we could have done. And in fact, for a long, long time, we were sort of working out, like, what exactly do we want to do with all this amazing technology? But, can we do all of it? And when I came in, I was quite keen that we didn't try and do everything. By the way, to our conversation today, that has been an ongoing discussion about how much we do and what we do focus on. But from the very start, I tried to sort of set the team up so that we weren't going to do everything. We called ourselves Orca Computing for a very good reason, to keep reminding ourselves that we're trying to do computing. And if we'd have called ourselves, and this was discussed, if we called ourselves Orca Quantum or Orca Photonics, then we could have maybe not had that clarity. So right from the very start, we got together as a team to focus on computing and quantum computing. And the reason for that was a few different reasons. From the technology side, from the academic perspective, they saw a great potential to see their research realized, in general, where they sort of came from a tech push point of view. They wanted to see their stuff made real, made more robust, and all of this type of stuff. But from my point of view, and maybe I've always had a more market-facing point of view, I saw that a lot of existing computers were moving more and more to photonics. So more of the computers that we rely on have on the inside more and more photonic components. And also there's this huge overlap with the world of hardware making machine learning better. So even though I wasn't totally from the market perspective, I think I was really keen on what the application of this cool stuff could be for computing. And, I guess the coming together of those two themes landed us squarely in the middle of photonic quantum computing, which is what we do. But that there are a few different perspectives that I think came together to make us really excited about what we could do in the world of computing with our photonic quantum technology.
And I suppose a certain amount of that kind of ambiguity, if you like, that it's not always 100% clear, I think, with any group of founders. You're not an academic founder, but you are a founder of the company, generally speaking, as its market face and CEO. But I wonder if that, how common that is, for that. And I wonder if there's a piece in the company's history around, we wanted to do computing. And if it's more quantum related, then great. It's more photonic related, great. but we want to do computing for particular applications. Would that be fair?
Yeah. From my perspective, definitely. So, I mean, I definitely saw, this huge sort of almost gaping hole where technology hardware could be better. Computing hardware could be better. I spent my whole career watching computers evolve. I do quite often focus on where I think the biggest market is, and it's not that hard to see that there's a massive interest and market for computers, even when we started 6 years ago before the AI boom sort of kicked off. And I think that's really important because I think with photonics in general, you can do a lot of stuff with photonics. And I think a lot of photonics companies end up in what I sort of call research mode, where they get really excited about serving the research community to build a new microscope that might serve another researcher. And to me, that all sounded just too small. And it is sort of in the world of computing that I see a really exciting need for new technologies, new ways of doing it. And then all the way up to the top, because of what we now know, that computers use loads of energy. That's sort of worrying for all of us, how much energy computers are using. Also, I always say this, and I always think it's true, that existing computers just aren't very good at lots of things. So we really, I stood up on stage a few days ago in front of lots of people and said, just think about how bad Siri is. Everyone loves to talk about AI, but let's just be honest with ourselves how bad things like Siri or satellite routing, GPS type systems are, and things like this. Computers just are really not very good, and we like to think of them as human, but they're a long, long way from being any type of sort of having the computational power to be able to be more natural in the way that they approach things. So,
or maybe our expectations have become completely, our expectations are increasing, because I think if you compare them to, probably computing standards 5 years ago, they're much, much better. It's just now our expectations are that much greater.
That's true. Yeah. And we all expect those computers to be in our phone as well as performing this human-like interactions. So but I mean, the big picture is that I do love the idea of computing. I love the idea of us as humans being able to process information. But I do really passionately believe that computers could be a whole lot better. And at a very sort of surface level, photonics has always been this technology which had the potential to completely change computing. So people have been talking about photonic computers without the quantum part for years now, for decades. And there's never been a moment where that made sense. And now we've got the convergence of, maybe new ways to do computing, photonics, with obviously the urgent need for new types of computers driven by AI and our expectations that computers should be better. So it seemed to me like the most amazing moment to just apply some very new technology. But the need for that new technology has never been more pertinent, in my view.
So the end goal, however, is still to develop full stack, fault-tolerant quantum computing capability. Is that right?
Yes. Well, on our technology roadmap, that's the end point that we observe. But maybe if I was to unpack that a little bit, I think as a company we've changed quite a lot. So that if I was to describe our vision, it is to build useful quantum computers. And those just might happen to be fully fault-tolerant quantum computers, or they might not. But the thing that now is our sort of North Star is it doesn't matter what the technology is. We want to see them being useful. And you're smiling because I'm sure this is what we'll get into a lot. But there's such a drastic difference between being sort of guided by a technology mission. And, the worrying thing there is that technology mission might be wrong. You might get it wrong versus a more market-led mission. And in everything related to how the company approaches things, we're trying to, and I shouldn't present it as a completed task, but we're trying to move everyone onto this new mission of just, doesn't matter what it is, but what we're trying to do is build useful, commercially useful, valuable quantum computers in whatever technical form that may take. And that's worrying for lots of people because it's so much more ambiguous. It's harder to define it if it's not one very specific technology, but it's like, it's useful. What does useful mean? We don't know. Let's find out.
Yeah. But I think especially in deep tech, I think this is relevant. we're going to come back to all those points you just mentioned because they're very, very relevant, and I think they represent maybe compromises or trade-offs is a bad term. I don't mean that in the pejorative sense. I mean it in almost the practical sense, and maybe in a sense that forces us to take a look to reevaluate what our real intentions are here. We see this in AI. There's a lot of talk about realizing AGI, putting the safety concerns to one side for a minute, but without necessarily understanding of the pros and cons of realizing that goal. And I think deep tech innovators, and I think true fault-tolerant quantum computing capability is another one of those goals. We want to do that. I think scientists and engineers within the deep tech communities are particularly good at focusing on a goal like that and then just going for it, regardless of the benefits.
Yeah.
Almost to demonstrate, least of all to themselves, that it can be realized, that it can be done, that they can use their powers of logic and reasoning and brilliance to accomplish such a difficult a task, a challenge. But then, of course, you rightly bring up, and you ask the question beyond it, which is, but to what end?
Yeah.
And if we're going to apply such an enormous amount of capital and investment, not just in terms of finance, but in terms of human capital as well, and energy and resources, all of the stuff that goes into building and realizing all of these innovations, because it's not just money, is it? We know it's not. So, then for what benefit? And is there not something we can do? Should we not be considering this potentially from a different perspective?
Yeah, I totally agree. One about that trade-off point as well, because I think one of the things I've observed is that when you get started with a new technology, it may be in a university research lab, you might have a sort of technology vision, but often that's completely unconstrained. We want to build a fault-tolerant computer. That's it. That's the thing that will win us the Nobel Prize. And beyond that, it doesn't really matter. But we all know that in the world of real technology and business, there are lots of constraints. And I think actually, by the way, working within constraints can be a really creative process. But you've got to learn to do that. And that constraint might be, well, okay, we can build this thing, but at what cost? At what cost to the customer? What value will it provide? Or any one of a number, like a time frame. Like, we want to build this thing, but do we want to take 15 years to build it? Do we want to take 10 years? But adding in constraints to your definition of the technology vision you have in order to lead to a more sort of outcome-driven mission, more application, if you like, driven mission, I think is really important. And it's so hard for people. One of the things I've noticed employing people who tend to come from a university background is they hate me telling them, or the market telling them, constraints like, oh, you could do this, but you're not going to, because if you do it this way, this is not going to be, you're not going to build this thing any less than $1 billion, for example. So we're not going to do that. That fundamentally challenges them, I think, because they're driven by the science, they're driven by, building this thing that no one has ever done before. Yeah. So I think that's a really important challenge.
Yeah, I like the point you raise on the piece around constraints and how constraints can actually be what's required in order to realize an innovation or a pathway to part of the innovation. And it reminds me of airplanes and the Wright brothers. I don't know if you know the story, but when they were trying to get the planes off the ground, literally, there was another group, a consortium of wealthy benefactors and individuals who came together and applied a resource intense group to build airplanes and to get them off the ground. And they had lots of people, lots of smart engineers, and lots of capital to be able to do it. And then you had the Wright brothers, who had none of that, and it was a few of them. And the Wright brothers won. They were the first ones to get, that's why we remember them and not this other group, because they had constraints. They had
Yeah.
capital constraints and they had the human constraints. And so they had to figure out things in a different way. And I think with deep tech innovators and deep tech innovation generally, particularly in 2025, we're in an age where it's easy to think about the absolutes and the realization of these absolutes and only think in terms of absolutes, but to forget all of the wonderful benefits which may emerge along the journey, which we haven't quite put a label on, and which may not represent the absolute realization of goal, but may wind up delivering a huge amount of value nonetheless.
Absolutely. It's a funny story that when we first got started, I should have said this when we started talking about the introduction to Orca. When we first got started, we raised a pre-seed round that was £1.5 million. So we got started with a tiny amount of money. And I remember us sitting in this office and we were talking about what we might do. And it was so obvious to us at that point that we weren't going to build anything substantial with the funding that we had, along the normal path of just, okay, let's just go out and build this massive system. So we sat down around the table, what can we do with the money that we have available? And we came up with a much more resource efficient method of delivering a very first quantum computer. And that was great for us because that meant we could build the system with just one. It was cool because we just had one quantum light source and one detector rather than tens, which other people might need. So it was good for us because we could do something, but then we quickly found it was really good for our customers because we could do something for them as well for that same amount of money. So this very early on, we were constrained and had to be creative to learn to work within that constraints. And okay, there is a trade-off. I don't think you want to be too over-constrained too often, but I think a certain amount of constraints or limits to resources at your disposal stop you just being somewhat idealistic maybe in the way you approach things, and do force you to be much more grounded. And I think that does actually drive innovation in a useful way. And great, maybe one day I'll compare us to the Wright brothers. But,
yeah.
So
Yeah. Well, how difficult was it to convince your colleagues to pursue a commercial line and as opposed to the ideal?
Funnily enough, I think back then it was very easy because everyone could see the constraints. Here's the money we've got. What are we going to do? Let's do this. That's great. I think then when you come into more resources, then maybe more of the challenge comes. The question will be, well, we've now got more funding. We've just secured a bit more funding or something. Why are we still pursuing this constrained model? Why don't we just flip over to the, idealistic model of building quantum computers? And it's funny, it's hard then to explain, well, that's because that's what, and it's not that the market has spoken. It's not as easy to say that we've got all these customers lined up for this more resource constraint, because you have to sell a vision. And that vision is that I believe that if we constrain ourselves to build quantum computers in a more useful way, that the market is bigger for that. But that's something that you can debate. People can disagree with me and say, well, actually, I disagree. I think that actually these much bigger quantum computers have a much bigger market potential. So I think the challenge comes later when you have the option to pursue a much less constrained approach, maybe a much more scientific approach. We're always having to explain why we believe in listening to customers, as crazy as that sounds. Why? But in the world of quantum, do our customers really know what quantum computing should look like? And I think that to an extent they do. Of course they do. They know what a computer looks like. They know how much money they'll spend on a computer. And the fact that it's a quantum computer doesn't change that. So it's an interesting thing and by the way, it needs constant reminding. I constantly have to sort of reiterate with my team and also to investors, this is what we believe. We do believe in this more commercial, the commercial reality behind quantum computing, rather than a more idealistic version.
Yes.
I call it a religion. Sometimes I say there are two religions in quantum computing: those that believe in nothing but large scale fault tolerance, billion-dollar systems, and we have a different religion that's about more immediate usefulness, commercial relevance, value. And they can align, of course, but they are to a certain extent quite different sometimes.
It is a different path. It is a different path. I love the point you raise about the constraint. When the constraint is lifted through additional resources like finance, suddenly that focus goes away, or can get a little, blurred. We on one of the recent podcasts we talked about this a lot. How one of the real challenges for a lot of deep tech companies, especially with fairly young teams, is the pressure of so much capital. And how when we can often start to see things go wrong. I'm not, by the way, making a case to limit the capital you give to deep tech companies at all. But it's how we react to the largesse, to having that resource. It's the pressure we feel as humans, and our ability to deal with fewer constraints, and then the creeping back of that idealism and what we might build.
Yeah,
that's a real pressure.
It's so important to me, and then maybe the way I do things, it's a sort of strange wanting to make life slightly harder for myself or ourselves as a company than maybe we could do, because we want to constrain ourselves and want to make sure that we think carefully about what we do to make the most of even when we've got more resources, make the most of the resources that we have. And by the way, I think in this world of quantum computing, there are other companies with almost limitless amounts of resources. You mentioned Google, IBM, also privately funded startups have essentially infinity money right now. So you have to think to yourselves, and actually we went through a big thought process about a year ago where we thought, well, if we also operate in a totally resource unconstrained way, all we're doing is following the same path, but $990 million fewer and 3 years behind. So we've got to constrain ourselves in some way. We've got to think differently. Otherwise, we're just going to end up at the same point, but 3 years after those other, if we're lucky, 3 years after. So we definitively decided to take a different path, to be much more commercial, and also to think harder in order to constrain ourselves according to what we thought the needs of the customers are and should be, in order to make ourselves competitive. And it's always quite funny. Like I do think that we are still competitive with those companies that have raised way more money than us, because we've just had this much more commercial approach, and because we've made life maybe a little hard on ourselves in order to apply these constraints.
I can believe that. I can definitely believe that. One of the things I've observed especially in the field of quantum, where you have a number of different players who are trying to build fault-tolerant, full-stack quantum computers, is the ultimate decision that's pending around focus. What are you ultimately really going to focus on? Because if you're doing everything from the quantum development to the chip design to the cabling and the distillation refrigeration, cryogenics, and the firmware and the electronics and the software and the application layer, and it's just so much. There is so much in there, and it's not cheap. It's definitely not cheap realizing all of that. And so even if you raise a big round and if you have lots of people, that money is going to go pretty quickly. Yeah. You postpone that make-buy decision that most other established technology companies have to consider. Where is our core focus? Where can we deliver the most value? And what are we going to rely on partners for in order to build ultimately a successful company?
Yeah, you're right. Actually, make-buy is one of probably the hardest decisions that I think we have to make, because mostly driven by the fact that so often it's more natural for the team to approach it if they just make it themselves. And it might take more resources, to your point, but you've got complete control over it. It's easier, right? But the bigger picture is, well, no, actually, firstly, it's much more efficient if you do it another way, if you focus on what you do well and you leave everything else to other people. But also, if you invest the time and the effort into that, but that investment, by the way, takes a different skill set. To outsource a technology to a supplier is a much different skill set to being a physicist and building stuff in the lab. So it requires it. So you almost by default fall into the way of working, which is just, well, we need more money because of course we're going to do it all ourselves, rather than again thinking more efficiently in a more focused way. And well, we don't need to do this. And actually, here's a great company over here, and it's going to take us 3 months to get that company up to speed. But once they are, and by the way, they can also ramp up production if we ever need them to. So much more. I think it's a great example, make buy, because it's just so often seen as a default option. There's only one way of doing it. But when you operate in a different way, focused towards achieving some commercial outcome, you've got to do things differently. You've got to think in a different way. Outsourcing can the buy side can be much more important.
Yes, it can. You've mentioned customers a lot, and you had in our earlier conversations too. Do you think customers understand the quantum offering? Do they feel, and let me kind of expand on that question a little bit. Do they feel, well, this is going to be like classical computing, and I'm going to type some stuff into my keyboard here, and it's going to just produce more accurate stuff? Is that what it is? Or do they, and I guess it's depending on the software. Maybe it will be. Maybe it will be, because software will determine that to an extent. Or do they see it as a truly new computing paradigm?
Really good. I don't think they know. I don't think they know. By the way, I was going to be slightly provocative in saying that I don't think a lot of quantum companies know the answer to that question either. So it's not like we're helping with that uncertainty. I think, and this I think describes the promise, or maybe the potential promise, but also the opportunity of quantum computing. It can be both. It can be one or the other. It can be more of an accelerator to an existing computer, or it can be a completely new thing, unlike anything they've ever seen before. And those customers, they don't know. Right? They don't. I mean, they might have employed some quantum physicists, but they're relying on the vendors to tell them. And I think then the vendors don't really know. There's, like I said, there's different religions, so it doesn't help they talk to two different vendors and they get two different answers. So I don't think it's as easy as just saying you can just listen to your customer, because I don't think it's as easy just to say, well, we would just let this play out and see how it goes. I think it does require, so it's the starting point of a conviction that it works in a certain way. And then, to a certain extent, we go to our customers and we say, here's our vision for quantum computers. And by the way, most of them turn around and say, oh my goodness, this is much more understandable than anything I've ever, I've heard from so many different people, all of this confusing stuff about quantum is, half of which I don't understand, half of which doesn't seem to really relate to what I'm trying to do within my business. And finally, someone's actually explained it in terms of a value creator or a product. So I think that for me is the sort of initial moment where I think, you've got something where you propose something and the customer at least says, this makes sense. And then the next part is then to obviously move forward and validate with them to the point of them spending money and committing to you, and obviously, scaling up operations with you and things like that.
Yes.
I don't know if that answered your question. I think my answer is no one really knows.
no, but that's my sense. That's my sense. And I think it comes back to these, I wouldn't say arbitrary goals that we set ourselves as humans. Putting a man on the moon in 1969 was going to be a good idea, not just the fact that it was of limited value to put a man on the moon. We could, look at space rocks and those sorts of things. And but it was all of the second and third order considerations that extended from putting a man on the moon. All that we learned about science and engineering that gave way in some ways to this great era of innovation that we've had since. And I see that with quantum a bit. And I think one of the benefits of going early with customers is you can have those conversations with them along that journey. I wonder, and this, we're going to kind of glide into the topic of solutions and product market fit and products, and what are we actually offering here, and what are they going to be able to do that they couldn't do before, and how do we measure value? How do they measure value? But when you're talking to an audience of customers, And what they're looking, I'm assuming, is they're looking for some kind of competitive advantage. So so actually, it would be really helpful for you to discuss Orca Computing and where you guys sit in that customer journey. Who are your target customers? What kind of benefit are they getting? Because I know there's a strong machine learning component to there and a data distribution piece. So actually, before I kind of go down that, could you extend, could you talk a little bit about the solutions that you guys are kind of building and why?
Yeah, no problem. In fact, before we do that, do you mind if I just make a sort of more general point about all that, the sort of product market fit that you mentioned? So I don't think I mentioned yet, but actually before Orca, I worked for the UK government on I helped run their quantum program. And I think it's interesting because there is a massive difference between how countries approach innovation. If you've got a big innovation program and you want to see some succeed, so you just sort of, where the idea of innovation can be a lot more just related to sort of osmosis. You fund a few things, those things may or may not work. It doesn't matter because that company might sort of not succeed, but then the founders will go on to do something else that might succeed. In that world, just innovation can be a lot more like, let's say, like osmosis. You sort of hope that, eventually the right ideas coalesce on the right sort of right markets or the right product solutions. I don't think that model works at all for startups because we've only got one company. We've only got a small number of customers who we're hoping to build solutions with. So the idea of not being super focused on what exactly, and then, product market, iterating on that product vision with them super closely, but knowing that, 2 months wasted going down a road that you don't think will work out might be fatal. I think everything needs to be much less like osmosis, much more focused on where you really think the product opportunities lie. And I'm only highlighting this because I think this highlights the massive gulf of understanding between, say, government and policymakers talking about innovation, but quite often without sort of a lot of substance, without a lot of specifics, and potentially university academics as well. And then how companies operate. So sorry about that slight setup, but I think that was interesting.
We could have a whole hour on that alone.
yeah. But let's stop and because you set up nicely, and I shouldn't go through this without telling you more about Orca. So firstly, Orca with the way that we build our quantum computers with Photonics, the first thing it allows you to do is build these systems that look much more straightforward than what a lot of people imagine a quantum computer to look like. So our products, they look like normal server racks. So they're sort of black boxes. They roll off the back of a lorry. They get installed into data centers very easily. Without the picture that some people have of quantum computing is that it's a sort of golden chandelier, a lot of expensive equipment, and very different from the normal server-like boxes that customers and data centers expect. So that's the first half of what we do. We build these quantum computers, but in a way that looks completely different, much more practical, much more like what existing data centers, for example, are interested in using. But that only gets you so far, and because you could install a computer and in sort of computer in inverted commas, because no one really knows what on earth to do with this thing. And really, in the early days, we were largely sort of physics-led. We went to customers, talking to them about photons and qubits, and pretty much 100% of our customers had no idea what we were talking about. So we quite quickly realized that unless we had an application view, which actually is also in the way we allow customers to use our systems through the software layer, as programming environments, but also a link to applications, it's very, very hard for those customers to really understand tangibly what you do. So actually, from sort of the first year onwards, Orca spent a large proportion of our effort investing in applying our systems. And what the great piece of work that came out of that is firstly, the application, the link between quantum computers and generative AI. So applying quantum to existing generative AI models and actually demonstrating how quantum can make those Gen AI models better. We're just on the journey to demonstrate that, but that alone would be a game changer for the world of quantum computing. It would be huge. And then slightly more sort of boring, if you like, but also just as important is the way that we allow quantum computers to talk and communicate to with existing computers. So there was also a realization that quantum computers they're not a standalone thing. What they need to do is integrate. They need to be side by side with existing computers in a hybrid way. And to do that really well, you can do it in a sort of hand-wavy type way, in a way that customers don't think is very good. But we needed to really invest in we call it close coupling, close integration between the quantum and classical computers, so that those two systems can work really well. So well, in fact, that the user doesn't really see that they're two different types of computers, even though behind the hood we know that the quantum system is operating completely different from the classical one. We provide that integration layer so that customers can sort of understand what's happening, not see them as too different a thing, and easily operate with those things.
And so how will the customer know that they've got quantum capability? Will they be able to process more data or perform more complex tasks?
So the short answer is that in the performance that they're able to achieve. So, I mean, we do benchmark our systems to show a performance uplift. There's no point in working with these quantum systems unless they can be shown to be better. And in this world, the customers we speak to, they are all in on very, very detailed technical benchmarks of machine learning performance and things like that. So one answer would be that they see an improvement in their model. And the types of results that we've started to see are things like you can perform the same operation with fewer GPUs. So spend less money with NVIDIA, which of course is useful for lots of people. That also correlates to a potential very significant energy saving. And this is the one that maybe really gets me out of bed, knowing that current AI models consume an unsustainable amount of energy in a way that should really worry us if we're thinking about using AI sort of sustainably in the future. So the idea of reducing the energy consumption of those models not only helps, of course, with carbon footprint, it also makes them more economical. The final really cool result, which we're still validating, but if we demonstrate this, it would be a huge shift in the quantum market, is an ability for those AI models to be more expressive, to start to predict results that fall outside of the training data. So normal AI models are based on just lots and lots of training data. That's how they work, but they're normally quite constrained to working within the sort of more or less the sort of limits of that training data. As soon as you start to ask for data that falls outside that training data, it struggles. So, for example, say in the world of using AI to predict new molecules, which is where we spend a lot of our effort, the model will be very, very good at giving you a molecule or a new drug that looks very similar to an existing drug. Finds it much harder to predict a completely new drug and a new molecule that no one has ever seen before. In that world of completely new molecules, completely different types of data, we see that our quantum system can really boost the performance way away from the existing training data set. And if even a little bit of that ends up being true, of course we validated it, but that is huge. And that really, then you can start to think of your AI system as much more creative, which we think AI is creative, but the reality is not so much. So if even a hint of that is true, that could be enormously powerful in seeing AI evolve into much more creative tasks. Now, I'm not going to go too far down that road because all the results that we've seen are things like molecules, things like industrial processes, quite constrained things. I'm not going to talk about AI becoming cognitive or anything, but really tangible industrial results that come out of making AI slightly more creative, slightly more expressive, different from the training data. And that makes me really excited. And all the while building on this huge backbone of quantum computing, which we all know will keep evolving, keep getting better time after time, but now linked to an application that makes a huge difference if you can land it.
Yeah. It's very exciting to hear you talk about that and the benchmarks you guys are currently going for. It reminds me a little bit of the late 90s, early 2000s, when Oracle used to run this big campaign around their servers and the performance of their servers. And it was a very, very effective marketing campaign. It was generally in The Economist. They had a white backdrop and red lettering. Oracle servers run X percentage faster than IBM's or someone else's and use less energy. I don't think they ever said and use less energy. No one talked about it in those days, but it was that it was the clear benefit. It was a clear message. It was going to be useful for engineers who were looking for efficiency, or were looking for just performance. So it was all about the performance of their servers, but it got the message home. And I think that's something that I think customers can relate to. If they can say, we can do your job more efficiently, we can make your AI or your machine learning platform much more creative or more able to process complex tasks more accurately. As you rightly say, that's a game changer.
Yeah. And it's funny in quantum computing, because I think the last 5 years of quantum computing, if it's been that long, first quantum companies it sort of emerged about 5 years ago. So the last 5 years of quantum computing, quantum has survived on the basis of the applications are groundbreaking. We can invent new molecules and all that, but without being very specific. And about it being promoted as the first change, paradigm shift in computing that has been many decades. But I think now the customers are much more sophisticated. We've seen Goldman Sachs, we've seen BP invest quite heavily in their own quantum research teams. So they know that they need to land specific applications, which are above and beyond just the sort of generalities of, maybe it could do this, but don't ask me exactly when you'll be able to do this or what exactly it can do. So I do think it's not just Orca, but I think in general, the whole of the quantum computing market is shifting to be much more specific and needing to answer much more specific questions to industry, to customers on what exact. Fine, I get they can do lots of stuff, but what specifically can it do?
Yeah.
And when and how much?
Yeah.
And so I think that in general, the quantum industry is going through a pretty exciting shift. And obviously, there are lots of publicly traded quantum stocks at the moment, and they're having to answer this question as well. And so I think it's a sort of exciting transition from it as an exciting new area of science to, well, great, I get that, but what are the products?
And one question on that, you mentioned Goldman and BP starting to hire their own quantum scientists and engineers. Are they doing it to further enable their AI capability? Or are they doing it kind of as a standalone operation to see where that goes?
Hard to tell. I mean, I think historically they've done it as a general capability that they knew they needed to build up, mostly looking in general at quantum and what can it do. I think now almost, and I've worked in the world of sort of industry innovation and research divisions that are quite separate from the main body of the business. I think now that those quantum teams that have been set up, maybe on the peripheries of large companies doing their innovation piece, but let us know and we'll work out where it applies to the business. I think that is starting to shift to be research teams that are much more centrally located within the business. So I think historically it's been less linked to, say, AI or the specific applications, but I think that's changed. Actually, one great example was I spoke to someone who I won't name, but it's a great quote that they said that they within their team they labelled quantum advantage to mean when a big company invests in quantum computing straight off their balance sheet, and because they're able to define the business return that can be derived. That is the definition of quantum advantage, not some more academic label. That there's a lot of debate in the industry about what quantum advantage means, and this person apparently stepped forward and said, "Well, it means someone investing in it off their balance sheet." Of course, we all know what that means, how significant that would be.
Absolutely. That's very good. Let's talk about something else. The journey you make as an organization requires obviously certain skills, experience, and talents, and those skills, experience, and talents change over time. And yet talent is, such talent, the type of talent we're talking about, it's at a premium. It's scarce, and what is available is at a premium. So how do you think about the team, that recruitment of skills, experience, and talent, the way that's organized? What's your, what works for you guys?
Yeah. I mean, this is really at the heart of, I think, being successful in quantum is the team. The funny thing about quantum, which I think a lot of people miss from the outside, is because of the fact that quantum has never been an industry, there has never been an existing industry for the development of quantum computers. That means that almost certainly you cannot recruit people with a lot of industry experience in quantum because it hasn't existed before. So it's not so easy to say, oh, I'm going to go for the top 10 quantum companies and pick up someone with 10 years experience working on a quantum computer. I mean, you might find one person, but in general, that's not a talent sourcing scheme strategy that works. So that then means that either you go for the people who know a lot about quantum computing, but typically they'll be coming from a more research background. So they'll have to learn and adapt to learn how to operate in a more commercial environment. Or you have to go for people with a lot of industry experience, but then find the people who are capable enough of translating that knowledge into quantum. And the question of, well, those people, how deep can they go into quantum if they haven't studied it before? And maybe there are outliers, people who've studied quantum before, but and then stepped into industry a bit like myself. But there is a talent gap, and a pretty big one, of people who know quantum, who also know how a company operates, especially at the more senior levels. Really, really challenging. And that gets only even more hard for more product-related skills. The more, when we really look at the frontiers of product development for quantum computers, you're really talking about, like probably a Venn diagram of one, a very small number of people. So I think the answer is twofold, really finding great people who are versatile enough. Dare I say it's sort of creative and intelligent enough, but versatile enough to take on a new role that's different from what they did before, step into a new way of doing it, embrace a new technology, or embrace, or if they're coming from a research background, a bit of a weird, much more constrained way of working than they've been used to. So you've got to find the right sort of feedstock, if you will. And then inside the company, I think there's a lot of, I think training is too shallow a word, but bringing up, upskilling, all these words aren't significant enough to really describe the job of really working hard to make sure that your team members understand culturally what you're trying to do. That's maybe the hardest piece. Making a researcher understand the world of products and revenue is a big old cultural shift and a big thing, I think, sometimes for them to understand. And also just in terms of the actual skills that they have to be able to step into this and continue to evolve and develop as people into this completely different world of working.
Yeah.
Often.
Yeah.
But it's hard. It's really hard.
Your point around, so I want to touch on a few things you mentioned there, but your comment that training or development is too light a word, I forget how you phrased it, but it's too almost pejorative a term to use for what has to go on. It's funny how over the, I guess, last few decades, we've come to see training and development as almost a weak terms for what has to happen. And when the whole point of, especially of these kinds of environments, for anyone, quite frankly, for anyone, when you're operating at the limit of what's possible scientifically and technically, and so on, is to develop. We have to develop. We're always developing, but we see that as almost some kind of, it's got weakness around the term and around the connotation, especially in an area like quantum. And you outlined it beautifully there, and just the conflict. There aren't a lot of people who've scaled quantum computing. No one has done it. Okay.
Yeah.
And inside big companies or small companies, everyone's doing it for the first time. So if that's your kind of starting point, then what are you going for?
Yeah.
And all right, so okay, we're all doing this for the first time. So then, what are the skills we need to
Yeah.
give us a better chance of being able to do it? And we're all going to have to learn. We're all going to have to develop. Do you think that young scientists, especially coming, with outstanding provenance, who's have emerged from really first class institutions, universities, and so on, do you think they get that? Do you think they get that the journey, it's going to be tough. It has to be tough. You're going to feel like, I don't know, you're back in school again because there's so much to learn. Your learning hasn't stopped or peaked because you got a PhD and whatever from wherever. It's actually, you're going to carry on this journey and you're going to feel dumb again. Do you think they get that?
I think my honest answer would probably be no. I could be more charitable in saying it depends. It depends on a few characteristics, but I think unfortunately, I think sort of university teaches you that the physics is the hardest thing and the most important thing, and everything else is just easy and you can do it. And what's the big deal? I could do that if I really wanted to, but it's not something that's really that hard. So I don't really need to try very much. I think important to say that I think there are exceptions. I think that you have to sometimes try and spot the people who are less technically brilliant, who maybe have it. That's not the most important criteria. It is people who, and I could use a bunch of vague words that we use, which defy detailed description, but things like they're comfortable with ambiguity. Maybe even more of a stretch, their personality is one that is orientated towards learning and putting themselves in difficult positions outside their comfort zone in order to learn. I think those types of characteristics, to be honest, unfortunately are sort of sometimes trained out of people as they do a PhD. As a PhD, you are supposed to be the expert. You are not supposed to be uncomfortable if you don't know something or explain that you don't know something. There's a lot of sort of maybe arrogance or expectation that you just don't sign up, don't recognize those things as important. But I think if you can spot people like that, and we've got some of our best people are ones who really step into that. Okay, I've seen and I've heard a bunch of stuff that I don't understand. I'm not going to dismiss it and just be like, oh, I'm going to go home and have. But I'm going to really step into that and really try and understand and pick apart what happened today, why these events played out, why I didn't, why there were so many iterations on this proposal that I was trying to write and things like that, in order to build themselves into better people. Maybe coming back to one of the comments you made earlier, and I think it's important, the training bit isn't the hard part. Like, we recruit the most intelligent people you can possibly imagine. They get stuff immediately. They need to know, they need to understand why they need to learn that stuff. That's the harder part, the sort of the step into the training, if you like, the explanation as to why you need to know this. Not because as soon as they know they need to know it, they can learn it. They can sort of find, they can do a training course like the rest of us. But it's the wrapper around the training, the cultural piece, if you will, that I find even more important to explain to them.
But is some of that training or development, you are a very commercial organization, and we're going to build products for customers that they can use. So this is less about, again, getting back to the original point, this is less about going for the end goal now. It's a journey to get there. We may turn off at some point. We may find something even more interesting as we go. But now we're going to build products for customers that they can use. And so we need you, depending on the role, of course, we need you to get out and get in front of customers, start having conversations, and hear what they have to say. And not take it 100% as gospel. It never is. You've got to, thread the needle or read between the lines, however you want to describe it. But there's all this other work out in the market that and identifying or kind of figuring out where that market is going, what that customer is going to need now and likely to need in the future, and how what we're doing might align with that, how it could align that, and then getting to that point and being wrong, and then coming back and doing it again and being wrong, and until we get it right. That can be very difficult.
Yes. Yeah.
for individuals, for all of us.
I definitely agree. And really, the essence of this is really something that's hard to learn. Reading people, reading situations. So, for example, your customer's saying one thing, they really need this one thing. You might think that they're wrong, but working through that in a world that's full of ambiguity, there are very few certainties. There are very few wrong answers, but there are probably answers that are more right than wrong. This is a world that's really, let's be honest, it's really hard to navigate. All of us spend our whole careers learning how to do this, how to read situations, how to adapt to accommodate certain scenarios and feedback and things like this. And I think what's the most challenging thing about quantum computing is it's so much more, it has to be so much more accelerated, because the need for those people is now. You can't wait for people to sort of spend their whole career to figure out how to read a customer signal or how to interpret something that someone said, which is a bit ambiguous.
So what are the key characteristics or features? Can you describe, what are the key characteristics or features of talent when you're, getting away from the technical for a minute, because I appreciate that could change depending on the role. But what does an Orca Computing person look like?
We often, by the way, I'll say a bunch of stuff which my recruitment team always push back. We can't say that, it's too ambiguous. So what do you really mean by this? But we quite often use the phrase comfortable with ambiguity. And again, there's always pushback on how do you test for that? What does that really mean? But comfortable with ambiguity. And also, I think related to that, very strong sort of problem solving skills. So you notice a point of ambiguity, experience, track record of finding maybe unique, maybe resource constrained solutions to those challenging problems. And then slightly different from that, within a different set of skills, sort of commercial awareness. That actually comes third, really. If you can have those two things first, and then also commercial awareness, it's rare, but we'd be doing really well. But some sort of person who at least is willing or able to understand the commercial environment, the commercial side of, for example, what a customer will be looking to go through in order to, say, purchase one of our systems.
Yeah.
I'd say those three, probably in various different orders, probably summarize, outside of just we need a quantum PhD or someone who understands quantum optics, some of the things that we strive to get from our team members in what we do. Yeah.
Yeah. Richard, this has been hugely enjoyable. Thank you so much for spending this hour with me and us. I think where we draw that line when we're on that lab to market journey, trying to get to that ultimate destination, is really important. Resources. What I've taken away is this idea that resources are going to have a huge impact on our adherence to that goal, and that's a good thing. These constraints are a good thing, and they can lead us to other destinations. I imagine that that communication with the different stakeholders along that journey. One investor thinks she's signing up because I thought we were building this. Oh, and now it looks like we're turning off and we're going to do this. But hold on, my portfolio is going to be out of whack because the valuation changes and so on. Those kinds of things. I imagine that kind of communication is really important as part of that journey. But that is the nature of a deep tech journey.
I totally agree. And by the way, it's what makes this whole journey that much more fascinating.
That's it.
Personally, I get a real kick out of trying to solve these problems that we talked about today.
Yeah.
It's not a technical problem, it's a human problem. And crack it and motivate your teams to work in the right way. And that's the answer to being, a big part of the answer to be successful in your view.
Look, Richard, thank you so much again. Great talking to you.
Thank you. And you.
You've been listening to the Lab to Market Leadership Podcast, brought to you by Deep Tech Leaders. This podcast has been produced by Bauhaus. You can find out more about us on LinkedIn, Spotify, Apple, or wherever you get your podcasts.